The celebrity problem. Okay, so in this problem, what we can see, let me tell you the overall problem scenario. What is it? So let's consider there are n number of folks in a party, and it's like 0, 1, 2, n. Okay, and these folks are a part of the party, and in the party there is only one celebrity. And what is the definition of that celebrity? Let's consider this as X. That celebrity must not be known by anyone, but all the other 0 to n minus 1, excluding that X, should know this celebrity. For example, I will go through the descriptive problem. I will show you the descriptive problem too. So graphically, if I want to show you, let's consider 0. There are 3 people in the party, 0, 1, 2. And out of 3 people, if you can see, this arrow is representing A is to B. That means A knows B. A knows B in the party. So 0 is knowing 1 in the party. 0 knows 2 in the party. 2 knows 1 in the party. But 1 does not know anyone in the party. So it can be the celebrity. It is the celebrity. 1 is the celebrity. You can consider here. So let me, yeah. So as I told, like there are n people in the party, and those are labeled from 0 to n minus 1. Okay. Now I'm going to the descriptive part of the problem. In the n minus 1, so what is the definition of the celebrity? N minus 1 people should know him or her. What is him or her here? So him or her is the celebrity here. Okay. Now, how are we going to find the celebrity? The celebrity is going to be found like each and every person is going to ask, hey, do you know B? Like A is going to ask, hey, do you know B? Or B is going to ask, do you know A? And so on, whether A knows B. Now, the verification can be done by asking this problem. Like A knows B or B knows A. After that, we have been provided a helper function which is a boolean, which is going to return a boolean, knows AB. That is telling us A knows B, means whether A knows B or not. We are not going to implement this function, right? So it is going to tell us A knows B or not. So the function which has been given to us is like int n, find celebrity. Okay, and we can use this knows API, like where we have to tell A knows B or not. Okay, if there is a celebrity exists, you have to return that numbered celebrity, because the celebrities are numbered from 0 to n minus 1. If that celebrity is not existing, that what we are going to do, we are going to return -1. Now, as per the diagram, we can see what is the input has been provided to you. So don't confuse here with these inputs. The input will be an n. N is like the number of people present in the party. Okay. And what is this graph? This graph is for our practical intervention to understand how the how the people in the party are related to each other. Let's consider this scenario. For example, as I told, A arrows B, that means A knows B's. A knows B. So here also, if you can consider 0 knows 1 and 2 knows 0, 1 does not knows 2, 2 knows 1. Okay, the same graph is telling you the same thing. After that, you have to find the celebrity. You just want to give a try. Just let me know your approaches, what you think of. Okay, there is one constraint before going to that. So the constraint is like maximum number of allowed calls to the knows API is 3:n. I will come to that. I will come to that. So they are okay. So approaching this kind of problem, how are we going to do? So first thing, before you are going to try any problem, let me tell you my approach. So firstly, we have to understand the horror problem, the each and every essence of the problem. We should not assume anything. One thing. Second thing, what are the constraints available to the problem? So let me go through the constraint. So n has been provided to you, which is the graph dot length. Graph is the input. How many folks are present in the party? So it's from 2 to 100. So maximum 100 are the folks here. So the graph value will be either 0 or 1. That means a folk either knows or not knows. Okay. And one thing, a person knows himself. So that means the diagonal value, or if you are going to create a graph with a is to a, that is going to give you a 1. So let me show you this diagram. If you can see here, 0 knows 0, 1 knows 1, 2 knows 2, right? So in this way we have to approach the problem. So what is your basic approach? So firstly we have to go with the basic approach. What is that we are going to try? So one way you can say, what we can do, we can just iterate to each and every node, each and every fork, and we will just ask to other person like, hey, do you know me, or shall I or do I know you? So let's consider this. Let's understand with this an example. uh, Allow me to tell uh, that if the diagram is going to be messy or messed up, I will just try to clear it up. For example, 0 to n minus 1 has been provided. These are the folks. You have to find the celebrity. What is provided to you? Nose API, AB. What I can do, brute force. This is a brute force approach. Okay, brute force approach. What I can do for each and every folks present in the party. For each and every folks present in the party, A from 0 to n minus 1, B from 0 to n minus 1, I will ask everyone, hey, do I know you? Or for each and every folks, I am going to make a call to the nose API technically. Okay. Now, if I am going to do that, what I have to do, I have to use a for loop from 0 to n, and the other for loop, which is a nested loop from 0 to n. Okay. These are the two things. And for each and every I and j, let's consider this as I, let's consider this as j. For each of I and j, I am going to make a call to this nose function. Yes, that's good. That's good. But the problem here, what is the problem here? The problem considered with the question is like you have provided a optimization value of 3 is to n, 3 n, 3n. That means you can make API calls to this nose function only 3 times of the number of folks provided to you. But here, when the time complexity here going to the order of n square, that means this many number of calls are going to make to the nose API. So that condition is getting messed up. That nose API should be called 3n times. That is the problem with this approach. And your time complexity is also order of n squared. So what else we can do here? Anything which is coming to your mind, or you can just like, if we have identified 0 knows 1, okay, that means this can't be the celebrity. This can be not totally. We are up to the mark, like this is the celebrity. Okay, so up to this approach, what he has said, what we can do, we can just try to find a celebrity, a possible celebrity. Let's we consider or trying to find a possible celebrity. How we are going to find? So you can say, okay, we will go with a auxiliary data structure. Let's consider, I want to consider it as stack. I want to use it as stack. Okay, you can use set, list, anything you want. What is the essence of stack is, I want to put all the folks. I'm just using the number here from 0 to n. I am not going to say folks here. I will put all the elements 0, 1, 2. It's not there. Okay. 0, 1, 2 into my stack. Okay. Now, based on this approach, like, okay, this is one thing. This is one thing where if 0 knows 1 or A knows B, that means A can't be the celebrity, but B can be the celebrity. This is one thing. Okay. This is the one main point. Okay, so what I'm going to do, I will iterate my loop from 0 to 2 for all the nodes present in for all the celebrities for all the folks present in the party. I am going to pop the top two elements, and I am going to just compare 1 and 2. Let's say for this example, 1 knows 2 or not. We can just going to get it from here. 1 knows 2. Yes, 1 knows 2. That means 1 can't be the celebrity. Here also in this graph also 1 knows 2. Yes, 1 knows 2. That means 1 can't be the celebrity. What I am going to do, I am going to pop these two values, and if 1 is not the celebrity, I am going to push here. Okay, that means 1 got ruled out. This portion got ruled out. Now what is the second part? Second part is the same way I need to iterate here, like 0 and 2. Just pop it up. 0 and 2. Check. If 0 knows 2, yes, 0 knows 2. 0 knows 2. If 0 knows 2, 0 knows 2, then 0 can't be the celebrity. Who can be the celebrity? Yes, correct. But that is the case. Only this is the necessary and sufficient condition? No. Why? Because if you can see this here, 2 knows, okay, there can be a scenario, where 2 knows either 0, where 2 knows either 1, either or, we can't see. There can be a scenario. So in that case, what we have to make sure, the second point, that possible celebrity, I am just using the word as PC, possible celebrity. PC should know, PC should not know, PC should not know others. PC should not know 0 to n minus 1 should not know any one of them. But PC should not know any one of them. You can see here. But all others can know PC. For the possible celebrity, all others should know this possible celebrity, but the possible celebrity should not know the other candidates. Okay, so if you are going to find out, this is one condition got satisfied, and using this condition, like if the condition is like, you can see, if A not equal to B, and and if A not equal to B, and this possible celebrity does not know any one of them, and all other folks knows possible celebrity, then we are good. We got our possible celebrity. Else we are going to return -1. Okay, this is one approach. What else? What is the time complexity here? What is the time complexity and the space complexity? I want to make this session interactive, so you can just give a try. Not okay. Let me just tell you one thing here again. Like what we are doing, we are just running one time our loop to just put into the stack, which is order of n. Okay. For the second time, what we are doing for the second pass, we are just checking the condition whether possible celebrity has known by others, or this possible celebrity should not know anyone. That means we are running two passes, only two passes. So time complexity here will go to 2n, which is going to more or less order of n. What will be the space complexity? Yeah, here you will be good. Space complexity is order of n, the size of the input provided. Why? Because we are using auxiliary space, which is stack. Can we optimize it? I don't want to use space. Is there a way where we can't use space? So if we don't want to use space, what we have to do? If we don't want to use space, is there a way or not? So in that case, let me, okay, I am going to just use this diagram only. Let me, means allow me to tell, okay, tell me if you are not able to understand it. I'm just going to tell you the concept here only. So I'm just telling the optimal way, So here I have used stack in this example, and we are going to try the approach optimal. Sorry for my messed up things. So let me 0 1 1 1 0 1 1 1 1. Okay, so here what I am going to do, what we can do here, we can just try the possible celebrities. So start with 0. Let's consider I am giving my possible celebrity as 0. Let me change the color, it will be easier to understand. So sorry, I'm if you are posting something in the chat, I will look into this after some time because I'm in the flow. So possible celebrities, let's consider 0. For after 0, I am going to iterate to all other members in the party from 1 to 2. What I am going to do, I am going to check who is the celebrity. Means who is the possible celebrity. This is my assumption. I have started with it. If 0 knows 1, 0 knows 1 or not? Yes, 0 knows 1. That means 0 can't be the celebrity. 1 can be the celebrity, right? If you can just look into this example, 0 knows 1. 0 can't be the celebrity. 1 can be the celebrity, right? I reach to 1. Now my possible celebrity is 1. Now from 1, I am going to check for others. Okay, what else is remaining? 2. Okay, so for 2, 1 knows 2. 1 knows 2? Yes, 1 knows 2. That means 1 can't be the celebrity. Who is the celebrity? That means possible celebrity is 2. So I got to know like my possible celebrity is 2. Now, we have to optimize our first condition only. Second condition will be as it is. So for the first condition, we have not used any stack. We have just used out of one space to determine our possible celebrity. After determining our possible celebrity, we have just checked whether we are going to, whether this possible celebrity knows by others or not. So what is the condition for it? What is the condition? Let's consider if I am running my loop from I0 to n, this I equal to 0 to n. And what I want to check this possible celebrity I not equal to possible celebrity. For each I, if it is not equal to possible celebrity, and the next condition should be, if this is the one, and the next condition should be possible celebrity should not know others. Possible celebrity should not know others. But here, if consider, if possible celebrity knowing others, or knows, if possible celebrity, if others are not knowing possible celebrity, that means we are going to return -1, right? This is the condition. Else we are going to return our possible celebrity. Sounds good? So now let's code. Let me know this problem. Okay, so what I'm going to do, I'm going to just celebrity code the optimal approach. I am considering my possible celebrity as 0. Okay, so what I'm going to do, I'm going to just run my loop from 1 to n for other folks present in the party. For other folks present in the party, I am going to check if this knows, if possible celebrity knows this folk. If this is the case, what I am going to do, possible celebrity seems to be great, means big name will be I, right? And this will be continuous forever. It is going to find the possible celebrity. Now my possible celebrity has got out. Now what I am going to do, for int, this is my second pass, the second condition, 0 I less than n I plus plus. So in that case, what I am going to do, in that case I am going to check if I not equal to possible celebrity. Why I am using this? Because I knows, means I know myself, so that will be always true. If I not equal to possible celebrity and knows possible celebrity knows I or others, not knows, others, not knows possible celebrity, then we are going to return -1. Sounds good for this condition. Else we are going to return the return possible celebrity, right? Why I am using these kind of name you have to use in your interview, because this is going to distinguish you from other candidates if you are using proper names, naming conventions. Let's see how it goes. We are using nose. Okay, here we are using nose only for the 2 times. Maximum of, in the worst case, we are using in the 2n or more than 2n, but less than 3n in the average case. Let me run. Let's see how it goes. Fair enough. So, okay, let me try to submit. Yeah, it's accepted. And here's the time complexity. I am telling you about the 2 passes. These are the 2 passes we are using, right? And we are not using any space. Okay, moving to the next problem. Reverse words in a given string. Okay, so let's consider you have given words. Okay, what you have to do, you have,
Sorry, Jeet, sorry to interrupt.
yeah.
Can you explain why it's given like 3 star n, like 3n times in the time complexity? That
This thing.
yeah.
Okay, for this thing, actually, this is a constraint the question has added. Okay, just think in this way. If I am not providing you this constraint, that problem is fairly simple. You can solve in your brute force approach order of n square, but just calling 2 times the loop, the nested loop, what I have explained it in the first approach. So to make the problem somewhat trickier and to use some kind of greedy approach here, we are using here greedy approach. Okay, to make these type of functionalities, to make the problem smarter, to eliminate it from other problems, they have used this constraint. Sounds good?
Yeah, got it.